Come this way, please.
So tell me what's wrong.
Well, lately Spencer has been more tired than normal, and I've noticed the whites of his eyes are slightly yellow.
Okay, nurse, please order some blood and urine tests for Spencer.
The test results are back.
The blood test shows elevated levels of LDH. What could this indicate?
Lactate dehydrogenase, or LDH, is a marker for tissue breakdown. Erythrocytes are abundant in LDH, and thus high levels of LDH in the blood may indicate hemolysis is occurring in the body. Hemolysis may occur for various reasons, such as infection, a cell mutation, or an inability to protect themselves against oxidative damage. There is no evidence to suggest infection or a cell mutation, thus oxidative damage is the most likely cause of the hemolysis. In normal red blood cells, oxidative stress is controlled by an antioxidant tripeptide glutathione. NADPH is responsible for the reduction of glutathione. Without NADPH, no reduction of glutathione occurs, and the cell is unable to defend itself against oxidative agents, which results in hemolysis.
We also found abnormal levels of urobilinogen in the urine. Why could this be the case?
Well, the presence of urobilinogen in the urine and not bilirubin indicates that there is not a problem with the liver or bile systems, but rather that hemolysis is occurring, and this supports the results of the blood test. When hemolysis occurs, bilirubin is released. This is transferred to the liver where, when the liver is functioning normally, it is conjugated and excreted in the bile and metabolized to urobilinogen. During hemolysis, large amounts of bilirubin are released, which results in increased urobilinogen in people with a healthy liver. This increase of urobilinogen accounts for the yellowing of Spencer's sclera.
So what then could the possible diagnosis be?
Well, glucose 6-phosphate dehydrogenase deficiency explains all the symptoms. G6PD deficiency is an inherited X-linked recessive disorder in which the body doesn't have enough glucose 6-phosphate dehydrogenase. Glucose 6-phosphate dehydrogenase is the first enzyme in the pentose phosphate pathway. Therefore, any reduction in glucose 6-phosphate dehydrogenase limits the ability of the pentose phosphate pathway to work. While it's uncommon for such a severe episode to occur, the family history indicates a vegan lifestyle. Vegans often incorporate fava beans in their diet as a source of protein, which are known for increasing oxidative stress on the body. The pentose phosphate pathway thus has to combat this increase in oxidative stress. However, someone with a limited pentose phosphate pathway, such as in glucose 6-phosphate dehydrogenase deficiency, is unable to do this, resulting in oxidative damage to the cell and subsequent lysis.
Can either of you explain the significance of the glucose 6-phosphate dehydrogenase in the metabolic pathways of the body?
Well, glucose 6-phosphate dehydrogenase is the first enzyme in the pentose phosphate pathway, which is a crucial pathway for maintaining NADPH levels in the body. NADPH is important because it maintains functioning levels of glutathione, which enables us to combat oxidative stress. Anything that increases oxidative stress on the body, such as eating fava beans, puts extra pressure on this pathway. When it's working efficiently, it occurs in two phases, an oxidative phase and a non-oxidative phase. The first phase of the pentose phosphate pathway is known as the oxidative phase, and this is where NADPH is produced. NADPH production occurs through the oxidation of glucose 6-phosphate in a series of steps to yield 2 NADPH molecules and 1 ribulose 5-phosphate molecule. The non-oxidative phase can then take one of three pathways. The first pathway, ribulose 5-phosphate, can be transformed to fructose 6-phosphate and then enter glycolysis as a substrate to produce energy. The second pathway, ribulose 5-phosphate, can be recycled back to glucose 6-phosphate, where it can be reoxidized to produce more NADPH. This forms a cycle enabling the generation of more NADPH, which is required for combating oxidative stress as well as reductive biosynthesis. Finally, in the third pathway, ribulose 5-phosphate can be used in the synthesis of nucleotides to form RNA and DNA.
As a team, we have concluded that your son has glucose 6-phosphate dehydrogenase deficiency, which is entirely manageable if you avoid things which increase the oxidative stress on the body. To prevent further hemolytic episodes, foods which increase oxidative stress on the body, such as fava beans and high GI, should be removed from Spencer's diet. Regular but moderate exercise is recommended to help reduce oxidative stress, as is an antioxidant supplement program. Furthermore, removing toxins from his environment can also help alleviate the stress on his body.